Yeah, Assalamualaikum. My name is Muhammad Zafaris, and I'm the one that will do question 1, 3, and 5. Okay, the first program I'm doing is about swapping value between two variables using register and the SECR1033 instruction. Okay, now when I press F10, it will show this register. Okay, okay, when I press F10, the line 1 will execute and the value of VR1, which is 1, is moved into AX. And then I press F10 again, the line 2 will execute, which is 9, move into BX. And then I press again, F10, the line 3 will execute. The instructions swap the value inside AX and BX, as you can see here. Then I press again, then line 4, the value in AX is 9 and the AB and BX will be 1. And then I press again the line 5, the value in the BX become 1 and store into VR2. And then finally the dump wrap, they will display the register value and the program will end. Okay, that's it for question number 1.
Okay, so now let's move on to question 2. Okay, so here we declare four variable rval, the value is unknown, xval 26, yval 30, zval is 40. Okay, so now we run line by line. Okay, so for the first line is move eax xval, so eax value is now 26, and the second line negate eax. eax is 26, then negate, it'll become negative 26, then move ebx yval, so ebx will be 30, and then we sub ebx and zval, so 30 subtract with 40 will become negative 10, and then add eax, then ebx, and add negative 26 at negative 10, so it becomes negative 36. And then increment ex. So ex now is negative 36. Increment is like plus 1. So it becomes negative 35. And then the last line is move rval equal to ax. So rval value is now negative 35. So here's ex f f f f f f d d in hexadecimal. Okay, so that's all for question 2. Okay. All right. Thanks.
Okay, for the next question is question number 3, which is this program will perform arithmetic operation using EIX register. It will multiply VR1 and VR2 and add VR3, and the last one will decrease by 1 using VR4. Okay, now let's start it with line 1. We press F10. Should register. Okay. Then we execute on line 1, which is we will the value of VR1 we will store 5 and we store into EIX. Okay. Then we execute again the line 2. Okay. The mul VR2 instruction will multiply EIX by VR2, and which is 10, and will multiply 5 times 10 will become 15, but in this register we show in hexadecimal, which is 32. Okay, and then we execute line 3 and we'll add 20 in decimal, but in here we'll show 46 because it's in on the decimal and hexadecimal. Okay, then we execute again. The line 4 will decrease it by 1 and the x will become 45 because it will minus 1. Okay, then the final store will become 00045 hash. And that's it for the question 3.
Okay, now is question 4. So in question 4, we declare three variables. Okay, so first var1 is 40, var2 10, and var4 is unknown. Okay, now we run line by line. Okay, so for the first line is move ax var1. So now ax is 40, and then the next line move bx is 5, then bx now is 5, and then multiply bx. Okay, so now they multiply 40 multiplied by 5 is equal to 200, and then move bx equal move bx var 2. So now uh, bx is 10, and then subtract bx 3. So now bx become 7, and then divide bx. Okay, so 200 divide by 7. 200 divided by 7, then it will become 28. And yeah, now dx is 28, then here is 28 in hexadecimal. Okay, so that's all for question 4. Thank you.
In 5, this program demonstrates how the multiplication works in assembly language using MUL instruction. First, the instruction move the x will clear the x register. So the x become 000 hash, and next we move to the move x. This will load 1000 hash into the x register, and then we move to cx, and then with the 25 hash we store into the cx register. Good. And then the last one is the instruction mul cx. The mul instruction automatically use ax as one operand and store result into the uh, dx register pair. This one, and the calculation is 1000 hash multiplied with 25 hash will give to 25,000 hash. Okay, and then last step is the final register. This is what it shows. ADS has null store, and the ACX store 20, 25 hash into it, and that's it.
Okay, now we go to the last question, is question 6. Okay, so now we run line by line. Okay, so for the first line, dx 0. So now dx, so basically we clear dx, so dx is 0, doesn't have value. The value is 0. And then the second line, it move ax, we'll load 803 in hexadecimal into ax, and same goes to bl. We load 10 hexadecimal, then divide them. 803 hexadecimal divide by bl, 10 hexadecimal, and then we call dumb rex. Okay, so as this says that the high is remainder and low is quotient. Okay, so high is kosong. The high is 03 and the low is 80. This 03 in hexadecimal and 80 also in hexadecimal. So that's all for question 6. Thank you.